when we're talking about rational equations, f of x equals 1 over x is like the kind of the parent function, all right, of all rational functions. This is the simplest one. And we're going to work with this equation first. A rational function means there is an x in the denominator, okay? So it means we have an x in the denominator of a fraction. That's what a rational function is, or a rational equation. All right, and I put x in parentheses because when we deal with real world situations, maybe you're graphing distance versus time or something like that, the variable in the denominator is going to change. But there's always going to be a variable in the denominator. That's how we know it's a rational function. All right, this first example here, using this 1 over x, it says, let's only focus on positive values for x for this activity and not negative. All right. Imagine that you won the lottery and were given one big pot of money. All right. Of course, you would want to share the money with friends and family. If you split the money evenly between yourself and one friend, what would be each person's share of the prize money? If 3 people shared the prize money, what would be each person's share? So again, just asking, okay, you win all the money. So over here, this 1 represents like 100%. I'm getting 100% of the money. All right, this 0.5 represents like 50% of the money. So basically this side is percentages, size of the share. And then over here is like the number of people you'd be splitting with. So like if it's just me winning by myself, splitting with 1 friend, splitting with 2 friends, splitting with 3 friends, etc., etc. All right, so what I want you guys to do is work on these first 4 problems, write an equation for problem 4. You're just going to write an equation for each one, and 1 through 3, just try and answer each of the questions and sketch the graph. All right, so take a few minutes to work on these problems now. So we're talking about the first problem. It says, imagine that you won the lottery and were given one big pot of money. All right, so you want to share the money with friends and family. So if you split the money evenly between yourself and one friend, what would be each person's share of the prize money? So if it's just you and somebody else, half. You're getting half the money, they're getting half the money. That's when you're splitting it evenly. Okay, so if I were to graph this, say, okay, well, just starts out with me getting 100% of the money. Or if I split it with a friend, then we're each getting 50% of the money. And what happens if I split it 3 ways? Okay, so 3 people share it. Then I'm getting 33% of the money, which is going to be somewhere like right there. So this is like 0.3, so that means 0.33 is going to be probably right around there. And then it says model a situation with a table, equation, and graph. So let's start with the equation here. That was what was given to me at the beginning. It's going to be 1 over x, however many people I decide to split with. That's what we're going to end up with here. And then with 4 people, I get 25% of the money. With 5 people, I get 20% of the money. 6 people, 7 people, 8 people, 9 people. It's going to slowly start slowing down how we split the money after more people get involved. It's going to look something like that. We'll go ahead and sketch a line through there. It's going to be a nice smooth curve when we sketch it. And we draw through all those points. But the more people I split it with, the less money that I get. But it also drops in smaller increments the more we start splitting it with people. Okay? Let's think if we had something like, let's say the prize money was $1 million. Or we could say 1 million like this. All right, either way is an appropriate way to write 1 million. So if the prize money was $1 million, and I'm getting half of that money because I split it with one other person, how much money would I end up getting? How much is half of a million?
500,000.
You got it. It's $500,000. So it's saying, hey, I'm splitting this halfway. We each get 500,000. If I split it 3 ways, we each get $333,333.33. All right. And et cetera, et cetera. I split it 4 ways, we each get $250,000. All right. And then, like, what happens if I split it 1,000 ways? Well, I'm going to write the equation as f equals 1 over 1,000. And if I did 1 million divided by 1,000, what do we end up getting? We each get, was it $10, I think? Or was that not the right amount? I think that's right. So we each get $1,000. That's what it would be, $1,000. If I split it with 1,000 people. If I split it with 100,000 people, or there are 100,000 people splitting the prize, that's 1 in 100,000. It's a pretty small number. All right. And 1 in 100,000, we're just going to write it down really quickly. That is 0.00001. So that's like how the percentage of the money that I'm getting. Or this one was $10. This is the $10 example. So we each get $10 if we have $100,000 people splitting $1 million. Okay. Or the last one, 100 million people splitting the prize. We still each get money, but we each get a penny. All right, just 1 cent. If I had 200 million people splitting a prize, we each get half of a penny, so half of a cent. 400 million people, we each get a quarter of a penny. Notice that we keep getting closer and closer to one number. What number do we keep getting closer to? Like the more people we split it with. We keep getting closer to $0, right? So, yeah, so what's happening then, we keep getting closer and closer to $0. Are we ever going to get to $0 if I keep splitting up with people? Or theoretically, would I still end up with some little amount of money, right? If I split it with 1 billion people, with 1 trillion people, I still end up with a slightly small amount of money. Not much. It'd be fractions of a penny, but it's never going to actually hit $0. All right, it would get really, really close, but it never actually hits the $0. So what I'm going to do is we're going to talk about asymptotes, because that's a good segue. And what an asymptote is, it's a number the line approaches more and more closely. All right, that's the asymptote of value. Yeah, there's always going to be a little bit left. Exactly. Okay, it's going to get closer and closer. But we never quite get to that value, infinitely close. Okay. And what happens is, yeah, like I said, we get infinitely close, but we never get to that exact value. And when we draw this on a graph, we're going to draw it as a dashed line. So it's represented by a dashed line on a graph. So, and I should say, I actually want to rewrite the way I said it here because I said a number of line approaches. I should say, instead of a number of the line approaches, I want to say it's a graph or a line, the graph approaches. So I'm going to change that wording just a little bit. Okay, because the asymptote will be a line. It won't be just, it's not just going to be a single number. So I don't want that to be confusing for you guys. Okay. So whenever we end up with these rational equations, the general form's always going to look like this. Y equals A over x minus h plus k. So that might remind you of AGS3 last year when we had vertex form of a quadratic function where we had the h and k. It's kind of the same idea here with rational equations. There's an h and k. Notice the x is in the denominator of the fraction. Okay. Some key things that we want to look for when we're doing these graphs. We want to find the y-intercept. And the way we find the y-intercept is we plug in 0 for x. We want to find the x-intercept. And the way we find the x-intercept, plug in 0 for y. We want to find the vertical asymptote and the vertical asymptote is the h value. All right, whatever the h value is going to be our vertical asymptote. And then the last one, we want to find our horizontal asymptote. And the horizontal asymptote, oops, I said vertical asymptote twice. I'm going to erase the asymptote part. The horizontal asymptote is the k value. All right. So whenever we're doing these graphs, we want to look for 4 values specifically. The y-intercept is 1, so I'll write them down. The x-intercept, it's possible to have more than one x-intercept. All right, but usually there's only one y-intercept. We want the vertical asymptote and the horizontal asymptote. And I'm going to write those as VA and HA, just for abbreviation's sake. But that's the vertical asymptote and the horizontal asymptote. There we go. So that's your VA and your HA, horizontal asymptote, vertical asymptote, respectively. Okay. So whenever you're looking for the y-intercept, you're going to plug in 0 for x. So what this first problem is going to look like, y equals 2 over 0. Well, in this case, 2 divided by 0, that's impossible. You can't divide by 0. So this does not exist. It turns out for this problem, there is no y-intercept. We're going to say does not exist, DNE. Looking for the x-intercept, I'm going to plug in 0 for y. Hopefully the x-intercept gives us a little bit better of an answer. And I have to solve for x. Because there's an x in the denominator, I actually have to multiply the denominator by both sides. I'm going to multiply both sides by x. So I'm going to get x times 0, and the x's go way over here, and I'm just going to get 0 equals 2. Which turns out 0 equals 2 is not a true statement. So this one's going to have the same problem. the x-intercept also does not exist. This one's kind of a weird problem because it's got the x-intercept and the y-intercept, both of them don't exist. But, whoops, we're going to take a look at this equation a little bit closer now. Y equals 2 over x. There's like an h and a k that are both missing. And what's happening is we have this x plus 0 kind of going on over there. And then we're going to have a plus 0 there. And let me go ahead and draw this out. So it's going to look something like this. 2 over x plus 0 plus 0. So we end up having the vertical asymptote is just x equals 0. And the horizontal asymptote is going to be written as y equals 0. And it's just because that plus 0 at the end, there's no number at the end. So that's going to be our asymptote, is whatever the number was supposed to be there or wasn't actually there. That's where the plus 0 comes from. And the vertical asymptote is the h value. And we always want to think about the h value specifically as like whatever number makes the denominator of the equation 0 is what we want our value for the vertical asymptote to be. All right, now I'm going to go ahead and sketch this graph. I'm going to start by putting my axes together. I'll label my x and y. And I'm going to put a scale on there. We'll just count by ones in all directions. And it's literally just a sketch. I want to know what my intercepts are and what my asymptotes are. And in this case, it's kind of a tricky one because there are no intercepts. But I can go ahead and sketch my asymptotes. Sketch the vertical asymptote in yellow, the horizontal asymptote in blue, and I do dashed lines to represent them. Y equals 0. That's my horizontal asymptote. My vertical asymptote, x equals 0. All right, remember it's saying x equals 0, so it's saying for all the x values when x equals 0, y is going to be any number. That's why it's that vertical asymptote. And then I'm finally going to sketch my line here. Ooh. And what I'm going to do then is to sketch my line, I'm just going to go ahead and do a rough sketch and draw something that looks like this. Rational functions are always going to be in two quadrants where they're going to be opposite of each other. So you're going to have one on the top left of the graph and one that's on the bottom right of the graph. That could switch, and I'll show you other examples where we could see it switch which quadrants they're in, but they're always going to be opposite of each other, like diagonally opposite of each other like this. So since one was on the top right, one's going to be on the bottom left. When we have the x and y intercepts, it's easier to sketch the graph. And that's what example 2 is going to show us here. When we actually have the x and y intercepts, I think it's a little easier to sketch the graph. So example 2, we're going to look again for the y-intercept, the x-intercept, the vertical asymptote, and the horizontal asymptote. So for this one, y-intercept, start with that one. Y equals -4 over 0 plus 2 minus 1. Plugging 0 for x and solving for y. So I end up getting -4 over 2 minus 1. -4 over 2 is -2. So I end up getting -3 here. So 0, -3. That's my y-intercept. For my x-intercept, all right, and remember, you guys got to be able to show me algebraically how to do this. So it's important that you know how to do this algebraically. I'll start by adding 1 to both sides. And then I want to get rid of that denominator. I don't like denominators. So I'm going to multiply both sides by that entire denominator, x plus 2. Thankfully, I just have a 1 on the other side, because x plus 2 times 1 is x plus 2. So I get x plus 2 equals negative 4. And then I'm going to subtract 2 from both sides, and I get x equals negative 6. So my x-intercept was negative 6, comma 0. I plugged in 0 for y. I solved for x, and I got negative 6. All right. Vertical asymptote. Basically, I want to think about whatever value makes the denominator of the fraction equal to 0. In this case, I subtract 2 from both sides. I get x equals negative 2. That's how I find my vertical asymptote. Whatever value makes the denominator equal to 0. And then the last one, the horizontal asymptote, is going to be y equals negative 1, just because we had a negative 1 left over on the right-hand side. So that's how I end up identifying my horizontal asymptote. All right, now I can go ahead and sketch my graph. On this one, I'll just go ahead and center it again. I'll put my x and y values, and I'm going to go ahead and plot some points. 0, comma, negative 3, negative 6, comma, 0. I'll go ahead and label my graph to, there we go. And then I'll draw my asymptotes. X equals negative 2. Y equals negative 1. But now what happens is I have these intercepts, and they're actually in good spots where I can see which quadrants the graph's going to fall in. And see, one of them is going to be in quadrant 1. It's going to get super close to my asymptotes, but never touch them. It approaches more and more closely. And then my other line is going to be down here, where the other intercept is. So those intercepts help me identify where the two lines are going to be, where the two parts of the graph are going to be, which quadrants are going to be around those vertical and horizontal asymptotes. So it turns out here I've got a top left and a bottom right. All right, they're always going to be opposite kitty corners of each other. Okay. Now I've got two examples here. I want you guys to try these next two examples. So again, identify the y-intercept, the x-intercept, the vertical asymptote, and the horizontal asymptote for each of these examples. Take a few minutes to work on that. Show me your work algebraically to find those intercepts. You're more than welcome to graph on Desmos at the end to check your answers, but only to check your answers. On an assessment, I'd expect you to show your work to show me how to find those intercepts. All right, so give those two problems a try. Take a few minutes to work on it now. Let's go ahead and take a look at these two problems. So the first one, the y-intercept, we should have ended up with 0, 10. And then the x-intercept, we should have gotten a does not exist. The vertical asymptote, we ended up with x equals negative 1. And the horizontal asymptote, y equals 0. So I'll talk about the intercepts, or I'm sorry, I'll talk about the asymptotes, how to find those asymptotes. Are there any questions on the intercepts and how we get those, or are we feeling okay on the intercepts so far? All right, good. Let's take a look at the asymptotes. So for the vertical asymptote, because the parent function was this y equals, what did it say up there? It was a over x minus h plus k. It says, well, whatever the h is what the asymptote's going to be. But notice how it's negative 1 instead of positive 1. It's actually always going to be the opposite sign The best way I can describe it is you really just want to say, let's take whatever the equation is, or the denominator is, and set it equal to 0, like we do for our factored form, and then we're just solving for x. And in this case, I get x equals -1. So that's going to be our vertical asymptote for this problem. The horizontal asymptote is whatever number is being added at the end of the problem. In this case, there was no number being added, so the horizontal asymptote is just 0 because there was nothing being added. On the second problem, part B, I see a +2, so I can tell you right off the bat, hey, my horizontal asymptote is going to be y equals 2. That's kind of nice. That's easy. Okay. Vertical asymptote, I had an x -3, so I'm going to set that equal to 0 and add 3 to both sides, and I got an x equals 3. So that's my vertical asymptote. Okay. My intercepts for problem B, I should end up getting for the y-intercept 0, 10/3. But honestly, 10/3 isn't going to help me graph it too much, so I'm going to change it into a decimal, 3.33. When I'm showing my work algebraically, I should end up with a fraction, right? Something that Desmos isn't going to give me. And then I need to be able to write it as a decimal as well, so that it makes it easier to graph. And the x-intercept on the last one should have been 5, 0. And again, that's plugging in 0 for y and solving for x. That's kind of what this one looks like. Now, graphing these two problems, I see a 0, 10 for the first part. So I want to make sure that I can fit 10 into my graph. So I'm probably going to start with graphing like way down here or something. My x-axis, my y-axis. And my intercept is going to be at 0, 10. So if I'm counting by ones, 0, 10 is going to be way up there, and this will be 11. That'll be 6, -1, and -6. My vertical asymptote, x equals -1. My horizontal asymptote, y equals 0. And if I were to graph these on Desmos, the asymptotes aren't going to show up either. So, so that's what happens here with these particular problems. All right, there's a question here. It says, why isn't there an x-intercept on question A? So if we break down question A, what happens here is we said 0 equals to y, because that's how we solve for x-intercepts. And we have to get rid of the denominator to the fraction, so we multiply both sides by the denominator. And I'm going to get x plus 1 times 0. Anything times 0 is just going to equal 0. So the x plus 1's go away on the right side. And what happens is I'm left with 0 equals 10, which is just not true, not a true statement. 0 does not equal 10. That's not true. So that's why there's no x-intercept. There was one that doesn't exist. And then we verified that by proving that the horizontal asymptote is y equals 0, which means that this graph can't cross that line. It's going to get closer and closer, but it won't actually cross it. All right. So when I'm going to sketch my actual graph, I have the point 0, 10. I can sketch a line through there, kind of goes that way and then turns. And that means the other part of it's going to be down here somewhere, and I can sketch the other part. Even without knowledge of any points or anything like that, I can do a quick sketch still. All right, that's the idea with our graphing for practice A. Okay. Now for part B, I have 0, 10/3. Again, you end up with a weird fraction, so you can turn that into a decimal. And when I graph this one, let's see, I'll just go back to graphing in the center for this one. My x and y, I'll count by ones in each direction. I'm going to end up with a vertical asymptote at x equals 3. So I draw a dashed line there. I'm going to end up with a horizontal asymptote at y equals 2. And then I have a y-intercept at 0, 3 1/3, so just barely above 3. So it's going to be like up here somewhere. And then I have an x-intercept at 5, 0. So it's going to be over here. And that helps me identify, hey, those would be my two quadrants where this graph's going to end up. One of them's going to be over here somewhere. One of them's going to be over here somewhere. And they're both going to hit those points. That's how I can identify where those two parts of the graph are going to be. Any rational function, I should have two separate lines like that, and they're going to be opposite corners of the asymptotes. I can always double check on Desmos, but Desmos isn't going to give me fraction answers like I would need for the y-intercept here. Desmos isn't going to identify the asymptotes, so I need to know how to do that on my own. And I need to be able to show my work to find those intercepts as well. So always algebraically show your work, all right, to find those intercepts. Okay, so we have about 8 minutes left. For your first assignment of this quarter or semester, first three problems 1 through 3, graph the function on either a calculator or use Desmos, and you're going to compare the graph with f of x equals 1 over x. So what's the difference between the graph that I've given you and the parent function 1 over x? What's changed? Okay, problems 4 through 7, graph the function and algebraically solve to find the key features. So there should be plenty of room here for you to find the key features and then sketch a graph of the function as well. And again, it's a sketch. So as long as you can find the x and y intercepts and you can find the vertical and horizontal asymptotes, you should be able to sketch something that goes through those points. That's all you need to do for the assignment. All right.